So one of my students came to me who attends Westlake High School and Dawson Oaks, Calculus AB, Chapter 3 exam review. Question number 3 says, find the approximation using tangent line to find approximately what is 123 to the 2/3 power. This is a really interesting question because back in the days when I was growing up, we didn't have really powerful calculators. In fact, we didn't even have calculators in the early 20th century or the 19th century. So all of this had to be done by hand. And let's try to change this. First of all, I want to change this to an exponential state. So it's going to be the 3 is the denominator. The denominator becomes a root, right? So it's cube root of x2 squared. So numerator can go up here in the numerator like this, or we can also write cube root of x quantity squared. When you want to evaluate, it's a little bit easier to put the square on the outside instead of on the inside. Okay, that's put you a little 3 right there. So before we do that, we're going to look at the cube root function a little bit. Okay, the cube root function square looks something like this, just to let you know. Okay. It should be symmetrical to both sides. So anyways, that's what it looks like, kind of. We know that the cube root of 8 is equal to 2. Cube root of 64 is equal to 4. Cube root of 27 is equal to 3. Cube root of 125 is equal to 5. Do you see that? Cube root of 6 is equal to 216, I think, and cube root of 7 is backwards. Cube root of 216 is equal to 6. Cube root of 343 is equal to 7, etc. Okay, so cube root of 512 is equal to, I believe that's 8, something like that. Okay, I know my cube root functions pretty well. Anyways, so let's get the problem one more time. So accordingly, we're trying to find the cube root of 125 or 123 to the 2/3 power. That's the same thing as cube root of 123 squared. We know this is kind of like 125, right? The cube root of 125, we figured that out. These are the things that you have to figure out on your own, guys, okay? That's going to be 5 squared, which is 25. So this should be a little bit less than 25. Probably going to be a little bit less. It's going to be like 24.7, maybe somewhere around there. Okay. So what do we do next? We have to find the linearization because it's a tangent line, right? So how do you find the linearization of that? Well, we know that from our previous example, I believe it was problem number 2. It's equal to the slope times x minus your initial value plus y naught. And we know that our initial value, x naught, we're not going to use this value, we're going to use 125. Okay. How do you find slope? That's the tangential slope, right? This linearization function came from point slope form. Remember how we moved the y to the right side? So y naught would be like the initial starting value. The x naught would be the initial starting value. So, so let's find f of x is equal to cube root of x squared. That's our original starting function. It's an exponential state, radical state. F of 125, we know this value is cube root of 125 squared. Cube root of 125 is 5, squared is 25. That's my y value. That's my x value, 125. We have to find the slope now. How to find the slope? Well, here's your function right here. X to the 2/3 power. It's a little bit easier to differentiate if you have an exponential state. So I'm going to take the derivative of that, f prime of x, bring it on down, x, and then minus 1. 2/3 minus 1. Minus 1 is minus 3/3. 2/3 minus 3/3 is going to be negative 1/3. We don't like that negative. How to get rid of that negative? We bring it to the denominator. 2 over 3 times x to the 1/3. 2 over 3 times x to the 1/3, and exponential state is the cube root of x. There's your f prime of x, right? Your derivative. So now we're trying to find f prime of 125. 2 over 3 times, what's the cube root of 125? 125 is going to be 5. We found that earlier. It's going to be 2 over 3 times 5 is 15. That's my slope right there. I'm going to use red right there. And that goes into my slope right over there. Okay. Let's clean this up a little bit. You end up with the linearization of x is equal to 2 over 15 times x minus 125. That's your starting value, plus your y value for that, or function of that, would be 25. I'm going to distribute this out. We'll end up with 2/15 x. I'm going to distribute 2/15 times from negative 125. 2 times negative 125 is negative 250 over 15 plus 25. I'm going to add these up. I'm going to put over 1. To get common denominator, I'm going to multiply by 15, top and bottom. 15 times 25 is 375, and then over 15, so it's going to be minus 250 over 15 plus 375 over 15. 2/15x, and then plus that. That right there is going to be 125. 2/15x plus 125 over 15. That's your linearization of x. Since 123 is very close to 125, the linearization is going to be pretty close to the actual value. Okay. So I'm going to need a little bit more space. I'm going to put my values in now. It's going to be 2, L of x is equal to 2/15 x plus 125 over x. Our x value is at 123, right? It's equal to 2 over 15 times 123 plus 125 over 15. 2 times 123 is 246 over 15 plus 125 over 15. I'm going to add them up and you get 371 for 15. That's my final answer, which I believe when I worked it out was 24, and mixed number is 11 over 15. What I did with here was, if you can see it, I found out what 24 plus 11 over 15, that turns out to be 24.733. And if I did 123 to the 2/3 power, 24.7326. So cube root 123 to the 2/3 power should be approximately, since it's an irrational number, 24.7326. This is approximately, actually it's equal to 24.73 bar. Bar is another word for vinculum. So 24.7333, extremely close, isn't it? So there's a very small margin of error. I didn't have to use a calculator. If you were to calculate this out, 24.7326 would have been very close to that. Okay. Good luck on your exam.